Hi, welcome back to our new session, right? The new session. Last time we start to discuss about the increasing, decreasing interval of a function and about the first derivative test, which the first derivative test talk about that a function, if it's from increase to decrease, or in other words, f prime changes from positive to negative, then we get a relative maximum, right? If f prime change from a negative to positive, then we get a relative minimum at the critical point, right? Then of course, if they are that doesn't change sign on both sides, means both are negative or both are positive, then we have neither, right? The maximum nor the minimum at the critical number. Right, we have seen two examples already about the increasing decreasing interval and the extrema, relative extrema, and the leftover one example I ask you to try it, right? In the meantime, if you have the unit circle, that you can do the problem with no issue. Right? Of f of x equal 1/2 x minus sine of x in the interval 0 to 2 pi. So from 0 to 2 pi, we're looking for the relative extrema. Right, then we discussed before, right, to do this type of question, like involving the function doing the extrema, or later on, right, the other type of question like that, we first of all need to care about this domain, right? The domain of the function in the 0 to 2 pi, since it's trig function with polynomial, right, the trig function especially is sine or cosine, right? They defined everywhere. For the other four, they have vertical asymptotes, right? But for sine and cosine, they defined everywhere. The domain is just as given from 0 to 2 pi. Right, the next step is to find the derivative. F prime of x, that's 1/2 minus cosine of x. Right, then we could say, well, the official step to find the critical number is we're looking for the critical numbers. We're looking for where the f prime of x equal to 0, f prime of x is undefined. Right, either equals 0 or it's undefined. That we know that that defines everywhere, so we don't have any point or any x value that make f of prime of x undefined. We have equal to 0, that 1/2 equals cosine of x, which the cosine is positive on the first and fourth quadrant with angle of power 3, right, 60 degree, but in the view of radian, that's power 3, right? So we have the reference angle of power 3 on the first and fourth quadrant, that our x will be power 3, and for the fourth quadrant, that's 2 pi minus power 3 is 5 power 3. Right, that's our critical number. And of course, if we didn't limit it in that domain, right, it will be plus 2k times pi, for k to be integers, right, to be any integer, to which is at the multiple of the period, right? Every time adds the period of cosine, that can be also the solution, right? But that's what we have. Then we evaluate the f at pi over 3. That's 1/2 minus sine of pi over 3. Sine of pi over 3, which is, if you have a unit circle, you can find the value. That is radical 3 over 2. Find the y value. You don't have to make them into same fraction. Leave like that is good enough. And therefore 5 pi over 3, that's 1/2 times 5 pi over 3 minus sine of 5 pi over 3. And the sine of 5 pi over 3, well, since that is the same reference angle we have, the sine will be negative of the sine of pi over 3, right? That will be negative radical 3 over 2, which we change, become positive radical 3 over 2, right? That is our intervals. That is our point. Right, then at the end, later on, we try to see if what interval we're gonna get, and for the interval to be increased or decreased, then to decide what we'll have. Right? If either these points are maximum or these points are a minimum. Right, so to build a table, test value for the interval, that first one is from 0 to pi over 3, from pi over 3 to 5 pi over 3, and the last one is 5 pi over 3 to 2 pi. Right, to see about the sine of f prime of x, and what can we conclude about f of x. Right, from 0 to pi over 3, we can have the value of pi over 6. From pi over 3 to 5 pi over 3, maybe we can have the value of pi right in the middle. And from 5 pi over 3 to 2 pi, that we get is 11 pi over 6, right? Try just to get the angle that is in between, right? The angle value here, if we change to degree, right, that's 300 degree. Then we use next special angle 330 to get it as a special angle, right? 330 as 11 pi over 6. Then for f prime, right, the pi over 6, the cosine value is radical 3 over 2. If you use calculator, that is about 0.8 something, and 1/2 is 0.5, right? Then we get a negative value. You could just show steps here. 1/2 minus radical 3 over 2, we know that is negative. For the pi here, the cosine pi is -1, that is positive. And for 11 pi over 6, the cosine value go back to radical 3 over 2. Right, then we have f of x, that's decrease, increase, and decrease. I could write down the interval of increase or decrease by saying the conclusion that f decreases on the interval from 0 to pi over 3 and the interval 5 pi over 3 to 2 pi increases on pi over 3 to 5 pi over 3. Decreases on such interval, increases on such interval as we had. Therefore, the point which one? From decrease to increase, the point pi over 3 and the value is pi over 6 minus radical 3 over 2. Is a relative minimum, and the other point from increase to decrease is 5 pi over 3, 5 pi over 6 plus radical 3 over 2 is our relative maximum. Right, so that is the way, right, how we determine the monotonicity and the relative extrema, right? The increase-decrease interval of the f of x, right? If in the case we're given in the interval from 0 to 2 pi, right, of this function, and yeah, that's what it is anyway. Then from that we can decide increase-decrease interval and the point to be relative minimum or relative maximum, or neither, from the given function and on the given interval right inside. So that is how we find the increase-decrease interval and what is so-called the first derivative test. Right, that's what it is. Then the next section is the concavity and the second derivative test. The concavity is about the function is concave up or concave down. And that one is concave up, that is concave upward, and concave downwards is the other way looking. In the view of its tangent line, right, we have slope of tangent line that is from negative, very steep, and to not that much steep, and then go to the flat. Then it is going to be more and more steep. Right, that is in the view of tangent line. Right, it's from negative to 0, then to positive, which the f prime looks like is increase. And the other way that the tangent line was positive, then going to more flat, go down to 0, then move back to more steep in the view of negative way. We can see that it's positive tangent line, go to 0, then go to negative tangent line. Right, then go to 0, then go to negative, somehow negative, then very negative to very, very negative. not from very large positive to 0, then go down to a very negative number. For concave up, it is very negative, right? Go down to a 0, then go down to a larger positive number. That's what we can observe from the view of slope of tangent line. Right? If you know that the tangent line is has a slope that if that's not that much steep, that value is positively not that large, but when it's more steeper, that gets the angle to be bigger, therefore the tangent value, or in other words the slope, is more large, right? More closer to power 2 in the positive way, that will get more closer to infinity. Right? And for the negative part is similar. Get the negative value not that much big to a much bigger negative value, right? In the view of flat or steep. Right, so we have a conclusion, or definition anyway, saying that f is called concave up with f prime is increasing more clearly. We had discussed about increasing and decreasing, right? When we say f is increasing, that means its derivative is positive. When the function is decreasing, that means its derivative is negative. So for f prime is increasing, what that means, right? That is just means its derivative is positive. What is the derivative of f prime? Is simply the second derivative. Which in other words, if we just view the f prime is increasing, we do not know very straightforward, right, very clearly what that is. But if we view the second derivative, we can check that, well, it has criteria that the second derivative is positive. Right, in the view of f double prime, that is positive. Similarly, for concave down, we have seen, well, the slope is decreasing, that f prime is decreasing, which means our second derivative is negative. Right? Positive means up, negative means concave down. Right, so the second sentence, which is saying is f is concave downwards, when f prime is decreasing. More clear version to determine. Moreover, our f double prime, right, our second derivative, is negative. Right, so that is the definition of concavity, right? So if we're looking for concavity interval, we're just looking for where the f double prime is positive, that's concave upwards, where f double prime is negative, that means f is concave downward. Right, so that is the definition, and we use that as an aid to find out, well, what we need to find. Right, so test for concavity. Determine the open intervals. On which f of x equals v to the negative x squared over 2 is concave up. Or concave down. Right, if you have seen have taken a course called Intro to Statistics, you'll find out this is the probability density function of a standard normal distribution, right? That's the area underneath of the entire curve will be 1. And that area or that curve is before 0 that is increasing, after 0 that is decreasing, and statistically the mean, median, and mode is at 0 in the middle. And also what we will see is the curve, right? It's called point of inflection, which is change the concavity from concave up to concave down, from concave down to concave up at -1 and 1. That is the standard normal distribution. It changed the concavity at -1 and 1, right, for our x. We just see, well, if that is true. If you've taken statistics, you may have heard of it already, right? The point of inflection is at negative and +1, right? -1, 1 of the standard deviation. So we try, right? We try. The full step is similar as what we find for the first derivative. We just find the interval where the breaking point is normal called critical value. We'll give name later, which I had mentioned already is called P.O.I, point of inflection. And at that point, right, it's changed the concavity. So we just given that point, cutting our interval, and to see what will give us. Right, still first of all, domain is from -infinity to infinity. Since that is the exponential function, can take all the x, and the power itself is just a polynomial, right? Nothing else but a polynomial. So we use the rule to take our first derivative, that is e to the -x squared over 2 times -2x over 2. Right, that is -x times e to the -x squared over 2. Right, then double prime of x, we need to determine the u and v, right? Use product rule. U is -x, v is e to the -x squared over 2, where u prime is -1, v prime is, well, the v is simply just our original function. Then this result will be our derivative. By that, our f of x will become u prime times v plus v prime over v prime times u, right? Plus negative x e to the negative x squared over 2 times negative x. Which is a positive x squared times e to the negative x squared over 2. Oh, we get negative e to the negative x squared over 2 plus the x squared times e to the negative x squared over 2. We can factor this term out, and which left over is f prime called what? X squared minus 1. Then to find the change of concavity, to find f double prime to be positive or negative, we still need to find where the possibly f double prime equal to 0. Or f double prime is undefined. We're defined everywhere, nothing with nothing else we can find it. For f double prime equal to 0, we get that x plus 1, x minus 1 equal to 0, that x equals negative 1 and x equal positive 1. Right? And one thing we can concern that e to the negative x squared is always positive. So when we break the interval from negative infinity to negative 1, negative 1 to 1, and 1 to infinity, we only care about our polynomial, right? Still build the test value, right, for the sign of f double prime and for the conclusion for our x, of our f of x. Alright, the test value, we can take negative 2 in. That this e to the negative x squared is always positive. Right, since that's exponential function, right? Whatever power we take, that's always positive. Only the first term is making difference. For negative 2, for 0, or for positive 2 for these three intervals for test value. And we just substitute here, right? Negative 2 squared minus 1 is a positive 3. Therefore, whichever the e to the negative 2 is, right, that's always positive. And then for 0, that will be negative, and for 2 is positive. What we get is concave up, concave down, and concave up. Right. After we see the sign of f double prime, we know already what f of x looks like. Then f of x concave up on the interval negative infinity to negative 1 and 1 to infinity, concave down on negative 1 to 1. I like the curve we draw before. It is at negative 1 and positive 1 that changed the concavity, right? From concave up to concave down, then to concave up, right? Change from the value, right? That is our test of concavity. Right, similar as what we do for the test of increasing decreasing interval, we're just looking for the critical number, right? In the second derivative, it's normal called critical number, but similar thing we find. Right, second derivative equal to 0 or second derivative is undefined. Find the value or find the numbers, then we are able to build the interval to test for it. for rational function, determine the open interval which the graph of f of x equals x squared plus 1 over x squared minus 4 is concave upward or concave downward. I determine this one. Well, that is a tricky enough rational function. Right, so for the domain first, that's from negative infinity to negative 2, from negative 2 to 2, and the union 2 to infinity. Right, that domain is from the pre-calculus that the denominator should never be a 0. Right, we have all real number it can take, but exclude the negative 2 and positive 2, which will lead the denominator to be 0, or exclude those 2 points. Then for our f prime of x, I could just do it a little faster, I believe. U prime times v minus v prime times u. Right, which over v squared, right, which we'll get is u prime, that's 2x to the third minus 8x minus 2x to the third minus 2x, that will be negative 10x. Right, if you want to see the step, right, that's in the middle. That's 2x to the third minus 8x minus 2x to the third minus 2x, which is just negative 10x. Right, that's our first derivative over the square of our denominator, but which is still remain a function. So f double prime of x for sure looks like I will not have enough space, so right on the right side of f double prime, and we only use f double prime of x, so that's whatever it is. For first derivative we may erase that later, right? U is negative 10x, v is x squared minus 4 to the second power, u prime is negative 10, v prime is 2, x squared minus 4 times 2x, that is 4x, x squared minus 4. Right, that's all u prime and v prime. So I f double prime x over the square of v, u prime times v minus v prime times u. Right, we can erase the ones of x squared minus 4, become first power, become third power, cancel out. That is negative 10 x squared plus 40 and the plus 40x squared. Which is 30x squared plus 40 over x squared minus 4 to the third. That is our second derivative. Right, so that is the full process, right, to find the first and second derivative. So since the first derivative we don't use that at all, we could erase that and write the conclusion of what the second derivative x is. That's 30 times x squared plus 40 over x squared minus 4 to the third. And that is the second derivative, and I can erase that part still also. So clearly that's our second derivative, which we observe the numerator, that we get positive number times a non-negative times a plus a positive number. For sure the numerator is positive. Right, so the sign of second derivative only depends on the sign of the denominator. And the solving for 0, we're still looking for f double prime equal to 0, or f double prime is undefined. Right, it equals 0, we have no solution. Since we cannot get x squared to be negative in the real number base, right, so that's no solution. And for f double prime is undefined when only the denominator equal to 0. That is x equals positive or negative 2, which not in our domain. Right, so one thing is we don't have exist any solution. The other, f double prime undefined, we get not in our domain. Right, so for concave up and concave down interval, we only have is naturally separated by the vertical asymptote. That is 3 parts. Right, for test value, for the sign of f double prime and for the conclusion of f of x. Right, test value can take any value below, we can take whichever you want. Right, negative 4 is okay, 0 in the middle, it looks like it's easiest from negative 2 to 2. And we can take 4 as the value if we want it. Right? Then for negative 4 taking in, we get now the numerator is positive always. Denominator, that's 4 squared minus 4, is also positive. When the 0 taking in, the denominator becomes negative and positive on the third one. I can double check when you put your number into your f double prime to see what it will give us. Right, therefore, our conclusion is concave up, concave down, and concave up. Right, that we have f of x is concave up on the f of x, concave up on the interval negative infinity to negative 2 and from 2 to infinity, right, those interval, and concave down on negative 2 to 2. Right, at negative 2 and positive 2 we get a vertical asymptote, right, but each part they are concave up or concave down. Right, to be clarify what it is. Right. So that is interval of concavities.